After a long season marked by repeated cold outbreaks, widespread snowfall, and persistent wintry conditions, the atmosphere is beginning to send different signals. Across Western and Central Europe, temperatures are showing a clear upward trend, and for the first time in weeks, the weather feels calmer. In many areas, the first hints of spring-like conditions are starting to emerge. Most major numerical weather models are now converging on a similar solution, pointing toward milder conditions across much of Western and Central Europe. While this is not an abrupt or extreme warm spell, it represents a meaningful shift in the large-scale circulation, one that temporarily favors higher temperatures and a more zonal, less disrupted pattern. Earlier in the winter, Atlantic cyclones followed predominantly west to east or northwest to southeast paths, repeatedly directing unsettled, wet, and cool weather toward the Iberian Peninsula and parts of Western Europe. This configuration locked large regions into prolonged periods of rain and below-average temperatures. Current model guidance suggests a reorganization toward a southwest to northeast cyclone trajectory. This shift is critical. A southwest to northeast storm track allows much warmer air to be transported ahead of the cyclones, originating from the western coast of North Africa. As these systems move northeastward, they draw warm air north into Iberia, France, and gradually into Central Europe. At the same time, a significant pressure coupling is taking shape. The Azores High is extending and interacting with a zone of higher pressure centered over northern Africa, commonly referred to as the Saharan High. Together, these pressure systems create a well-defined corridor for warm air advection, reinforcing the transport of heat toward Western and Central Europe. Not at all. While conditions near the surface may temporarily resemble early spring, the atmosphere is still undergoing major changes at higher levels. A sudden stratospheric warming event is currently unfolding, a process that weakens the polar vortex and disrupts the stability of the northern hemisphere circulation. This warming at stratospheric levels does not eliminate winter, instead, it often increases volatility. Ironically, the incoming warm air may further weaken the polar vortex. As heat is redistributed toward higher latitudes, the vortex loses coherence, making it easier for Arctic air to escape southward later on. Even if the final week of calendar winter feels mild, this warmth should be viewed with caution rather than confidence. A weakening polar vortex combined with a potential return of the Arctic Oscillation into a negative phase increases the likelihood of renewed polar air intrusions into temperate regions. This winter has already demonstrated how quickly conditions can reverse, and Europe remains particularly vulnerable to sudden pattern changes. Another important factor is the delayed response between the stratosphere and the troposphere. Even if surface conditions appear calm and mild, the effects of the ongoing sudden stratospheric warming can take days or even weeks to fully propagate downward. Once they do, they can reshape weather patterns across the entire northern hemisphere, often in abrupt and unexpected ways. For Europe, this translates into continued vulnerability. Western regions may enjoy extended mild periods, while Central and Eastern Europe remain closer to the battleground between air masses. Under such conditions, sharp temperature contrasts, rapidly developing systems, and sudden changes in weather type remain very much possible. At this stage, the polar vortex no longer behaves as a single, coherent system. Instead, it shows a clear dual structure. One part of the vortex continues to function in a relatively stable manner, with strong westerly winds still circulating around a core of cold air, maintaining a degree of organization typical for winter. At the same time, another portion of the vortex is heavily disrupted, dominated by areas of anomalously high pressure and fragmented circulation. In this weakened sector, the usual confinement of Arctic air breaks down, allowing cold air masses to become increasingly mobile and prone to displacement toward lower latitudes. This split behavior highlights the transitional nature of the current pattern, where winter dynamics remain active but no longer fully in control of the hemispheric circulation. In other words, the warmth ahead is real and model supported, but it is also conditional. As long as the polar circulation remains weakened and the Arctic Oscillation unstable, winter is not fully out of the picture. The coming weeks are likely to be defined not by a smooth seasonal transition, but by volatility, a hallmark of late winter influenced by stratospheric disruption. Your support means a lot to us, so if you randomly stumbled across this video, and you made it to here, we would deeply appreciate if you would leave a like to the video and subscribe to our channel. Thank you very much for your attention.